The two best tips that I received when learning how to draw organic structures was that the number of carbons in the name has to equal the number of carbons in my picture, and to read backwards. Two ethyl hexane. Ethyl means dose, and hexane means 6. So I'm allowed to have 8 carbons in my picture. I'm going to read this backwards and draw hexane. I'm going to draw 6 carbons. 1, 2, 3, 4, 5, 6. I have 6 carbons here. Each corner and end is meant to be a carbon atom. The hydrogens are not drawn in. That's up to you. Imagine the other 3 hydrogens here because carbon bonds 4 times, so there's 3 hydrogens here. Those are 6 carbons. 2 ethyl. The 2 and the ethyl. This word ethyl means 2 carbons coming off of the main chain, the parent chain, hexane. This 2 is a location. So we start by counting 1, 2, and there are 2 carbons coming off of here. 1, 2. My picture contains 8 carbons total. 1, 2, 3, 4, 5, 6, 7, 8. Here is now this stick figure doesn't give much to the imagination. This is a model of 2-ethyl hexane. Here we have 1, 2, 3, 4, 5, 6 carbons. And here is the 1, 2 location. And here's an ethyl coming off of it. Now what this model allows train your brain to do is how this thing moves in space. This is an identical molecule. I've just only flipped it over. It's still in the 2 position. 1, 2, the ethyl. There's still only 6 carbons in the parent chain, but looks different. Now it almost looks like a cyclohexane. It's not cyclated. It's not. These carbons aren't bonded, but it almost looks like a cyclic hexane, cyclohexane, with a methyl coming off of it. Carbon molecules move and are always moving all the time. A very big skill. It takes a long time trying to imagine how these things look on a picture and comparing it to real life in your atomic vision. I hope this helps. Thank you.